In this video, we will be solving a few questions from straight lines. I have taken these questions from the Maharashtra Government Textbook 11th Standard Maths Part 1, Chapter 5, Exercise 5.3. In case if you want to refer the theory or sums of any other exercise, then you can check out the playlist and you will find the link for that in the description box below. Let's begin with the questions of this particular video. Write the equation of a line which is parallel to x-axis and at a distance of 5 units from it above it. Any line which is perpendicular to x-axis, its equation will be x equal to constant, and any line perpendicular to y-axis, its equation will be y equal to constant. So this line is parallel to x, means it is perpendicular to y, a line looking something like this. They have said that the line is at a distance of 5 units above it. Above it means above the x-axis. So if this is your x-axis, the line being 5 units above the x-axis, this point here is going to be the number 5 on y-axis. So because I said that if a line is perpendicular to y, the equation will be y equal to constant. That constant will be the very number where that line is cutting the y-axis. So the equation for this line will be y equal to 5. That's your answer for the A part. Going ahead with part B, they have said find the equation of a line which is parallel to y-axis and at a distance of 5 units from it to the left of it. So if again this is your coordinate, these are your coordinate axes x and y. The line is parallel to y means that it is perpendicular to x. It is at a distance of 5 units towards the left of y-axis. So the line is looking something like this. Because the line is perpendicular to x and it is at a distance of 5 units from y-axis, this number will be minus 5. The line is perpendicular to x, so the equation will be x equal to constant. That constant is the very number where this line is intersecting the x-axis at this point. So the equation of the line will be x equal to minus 5. And in a similar way, let's answer the third question. The line is parallel to x at a distance of 4 units from the point minus 2, 3. So again, let's draw it on this diagram only. So if this is your xy coordinate system, the line is parallel to x means it is perpendicular to y, something like this. And it is at a distance of 4 units from minus 2, 3. Minus 2, 3 is a point over here. And they have not said whether it is up or whether it is down. It's just parallel to x and at a distance of 4 units. So at a distance of 4 units, the line can be up also. And the line can be at a distance of 4 units down also. Now because this point was 2, 3, the y coordinate here will be equal to 3. 4 units above 3 means that this point here will be equal to 7. 4 units below 3 means that this point here will be equal to minus 1. So the equation of the line will either be y equal to 7 or it will be y equal to minus 1. Why is it y equal to constant? It is because the line is perpendicular to y-axis. And like we said, any line perpendicular to x, the equation is x equal to constant. Any line perpendicular to y, the equation is y equal to constant. Going ahead with the second question, you need the equation of a line which is parallel to x and making an intercept of 3 units on the y-axis. Parallel to x means perpendicular to y. It is hitting the y-axis at the point 3 on it. So the equation of this line will be y equal to 3. Perpendicular to y, so y equal to constant. Hitting at 3, so that constant will be 3. So y equal to 3 is the equation. Similarly for the B part, parallel to y means perpendicular to x. That means the equation will be x equal to constant. Making an intercept of 4 units on the x-axis. That is the constant here will be equal to 4. Okay. If I talk of this line, the line y equal to 3 is going to be a horizontal line like this because it needs to be perpendicular to y. This point here will be 3. So this line is y equal to 3. And similarly, x equal to 4 will be a vertical line like this, perpendicular to x, and this point out here will be equal to 4. Okay. So with that being clear, let's go ahead with the third question. You need the equation of line containing the point A and parallel to y-axis. The line is parallel to y means that it is perpendicular to x. That means it's a vertical line. And a vertical line passing through 2, minus 3. 2, minus 3 is a point somewhere over here. A vertical line through it. If the x coordinate of this point is 2, this number out here will be equal to 2. Because the line is perpendicular to x, the equation will be x equal to constant, and that constant will be this number where the line is hitting the x-axis. So the equation of line in question number A will be x equal to 2. Let's try to find the required lines equation in part B. The point is 4 comma minus 3. So 4 comma minus 3 is going to be a point somewhere over here. They have said that the line is parallel to x. That means it's a horizontal line, and a horizontal line will be perpendicular to y. So the line is going to look something like this. The y coordinate here, or the point here, will be the y coordinate of this point, which is minus 3. And because the line is perpendicular to y, the equation will be y equal to constant. The constant being this very number, that is minus 3. So y equal to minus 3 is the required equation of the line for question number 3, part B. Going ahead with question number 4. They are asking us to find the equation of line which passes through the points A and B. Because we know 2 points through which the line is passing, we will write the equation of line in the 2-point form, which is y minus y1 upon y2 minus y1 is x minus x1 upon x2 minus x1. Treat this point as x1 comma y1 and treat this point as x2 comma y2. So like I said, y minus y1, so that will be y minus 0 upon y2 minus y1, that will be 4 minus 0 divided by, not divided by, on the right hand side we have x minus x1, x1 is 2, so x minus 2 divided by x2 minus x1, that is 3 minus 2, and yeah, simplify this to get the equation of your line. This will be y upon 4 is equals to x minus 2 divided by 1. You can take that 4 on the right and say that this is 4x minus 4. And if you want to write all the terms on just one side, you can say that the equation of this line is 4x minus y minus 4 equal to 0. Okay, that's how we are answering question number A. Similarly, you can try answering question number B, passing through the points 2 comma 1 and 2 comma minus 1. Now this time don't try using that 2-point form, because when you go for 2 minus 2, the denominator on one of the sides is going to become equal to 0. You can say that if you plot the points 2 comma 1 and 2 comma minus 1, 2 comma 1 will be here, that is point P. 2 comma minus 1 will be a point here, that will be point Q. The line, if you see, is going to be a vertical line, and a vertical line means a line perpendicular to x-axis. For any line perpendicular to x, the equation will be x equal to constant. That constant will be the very number that you can see here. The x coordinate of the 2 points here is 2. So this point out here is going to be the number 2 on x-axis, and that is why the equation of that line will be x equal to 2. That's how we are answering the B part of the 4th question. Going ahead with question number 5. You need the equation of line containing the origin, that means passing through the origin, and having an inclination of 60 degrees. We will use the slope intercept form here and say that equation of the line will be y equal to mx plus c. Because it passes through origin, the y-intercept will be 0, and that is why c will be 0. So y equal to mx plus 0, that is simply y equal to mx is the equation. M was the slope of line. Inclination will be 60 degrees, inclination is 60 degrees, and that is why the slope m will be tan 60, which is equal to root 3. So when I put m as root 3 here, I get the equation of my line as y equal to root 3x. And yeah, that's how we are answering the first question. Similarly, let's try answering our second question. The equation of line passing through the origin and parallel to AB, where the coordinates of A and B are given. If a line is parallel to AB, then the slope of that line and slope of AB is going to be equal. So the slope of AB, that is y2 minus y1, which is 7 minus 4, divided by x2 minus x1, that is 1 minus 2. So this will give us 3 upon minus 1, which is minus 3. That's the slope of AB. But because our required line is parallel to AB, the slope of our required line will be the same as the slope of AB, which is minus 3. So the equation of our required line will be y minus y1 equals to m into x minus x1. I am using the slope point form for writing the equation of this line. The line passes through origin, so y1 and x1 will be 0 and 0. And we can put the value of m as minus 3. X minus 0 will be x, so on the right hand side we have minus 3x. Y minus 0 will be y. So the equation of required line is y equal to minus 3x. Or you can bring that 3x on the left and say that the equation is 3x plus y equal to 0. That's the equation of your required line for part B. In a similar way, you can try answering question number C. The line is having a slope of half and containing the point 3, minus 2. We need the slope, we have the slope of the line and we know a point through which the line passes. We know a point, we know the slope. So we will write the equation of line by using the slope point form, which was y minus y1 equals to m into x minus x1. x1 and y1 are the coordinates of the point through which the line passes. So y minus of minus 2 is what we have, equal to m means the slope, which is half, into x minus x1, that will be x minus 3. So on the left this will be y plus 2. You can take that 2 on the left. So on the left you will have 2y plus 4. And from the right hand side, when minus 3 goes on the left, this becomes, okay, fine, let that be 7. And now we can take the two terms on the right here. So we will have x minus 2y minus 7 equal to 0. And that's the equation of your required line for question number C. Let's go ahead with the D part. And in the D part, they are asking you the equation of line which contains the point and has a slope of this. So again, we know a point and we know the slope of the line. So we will use the slope point form for writing the equation. That will be y minus y1 equals to m, that is the slope, into x minus x1, which is equal to 3. Okay, we can take the 3 on the left. This becomes 3y minus 15. Expand the right hand side, that will be 2x minus 6. And bring all the terms on the right, so that will give you 0 equal to 2x minus 3y and minus 6 plus 15, making it plus 9 equal to 0. So that's the equation of your required line for point number D. Let's go ahead with the E part. Containing the point this and having inclination of 120 degrees. Now inclination of 120 means slope of the line will be tan theta, that is tan 120. Slope, that is m, will be tan 120. Tan 120 is like tan of 180 minus 60, that will be minus tan 60, which will be minus root 3. So we know the slope and we know a point through which the line passes. Equation of the line will be y minus y1, that is y minus 3 equals to m, that is minus root 3, into x minus x1, which is equal to 4. Okay, so we have y minus 3 equals to minus of root 3x plus 4 root 3. Take everything on the left, so you have root 3x plus y, then minus 3 minus 4 root 3 equal to 0. And yeah, that's the equation of line for part E. Let's go ahead with finding the equation of required line for part F. The required line is passing through the origin and which is bisecting the portion of the line 3x plus y equal to 6 intercepted between the coordinate axis. Okay, so we know that one point through which the line passes will be the origin and the other point is something which we can find from this remaining hint which has been given to us. The other point is bisecting the part of the line 3x plus y equal to 6 between the coordinate axis. So 3x plus y equal to 6. If you write this equation in the double intercept form, you can say that 6 comes on the left and the equation of the line will be x upon 2 plus y upon 6 equal to 1. It means that the x-intercept will be 2. That is, the point on x-axis through which the line passes is 2, 0. The y-intercept will be 6. That is, the point on y-axis through which the line passes will be 0, 6. This is your required line and the point through which our required line passes. Okay, the second point, one point through which our line passes is the origin. The second point through which our line passes is the midpoint of this part. That is this part of the line which has been intercepted between the coordinate axis. The coordinates for this point will be obtained by the midpoint formula. That will be 2 plus 0 divided by 2. And the y coordinate will be 0 plus 6 divided by 2. So this midpoint turns out to be 1, 3. And yeah, that's the second point through which our line passes. So our line passes through 0, 0. And our line passes through 1, 3. And that is why we will write the equation of our line in the 2-point form. So as per the 2-point form, the equation of line is y minus, let's treat origin as x1, y1. And let's treat this point as x2, y2. So y minus y1 divided by y2 minus y1, that should be equal to x minus x1 divided by x2 minus x1. Okay, so that's the equation of our required line. And if we simplify it, we will have x minus 0 upon 1 minus 0, which is simply x. And this will be y upon 3. That 3 goes on the right and we have y equal to 3x. And yes, that's the equation for part F. And with that, we go ahead with our next question. In the sixth question, they are saying that there's a line y equal to mx plus c. It is passing through 2 points. We have to determine m and c. Now see, if a line passes through 2 points, the coordinates of the 2 points are going to satisfy the equation of that line. So we will say that this equation will be satisfied by 2, 1, and that is why in place of x we can put 2 and in place of y we can put 1. When we replace x with 2 and y with 1 in that equation, we have 1 equal to 2m plus c. Mark it as equation 1. And similarly, because this line passes through the point B, the coordinates of B will satisfy the equation of this line. So in this equation, we can put y as 2 and x as 3. And by doing so, this equation becomes 2 is equals to 3m plus c. That is equation 2. If you subtract the two equations, then on the left hand side, 1 minus 2 will be minus 1. 2m minus 3m will be equal to minus m. And c minus c will be 0. So from here, we get that m will be equal to 1. And when we put m equal to 1 in, let's say, equation 1, you will have 1 is equals to 2 plus c. That 2 goes on the left and c becomes equal to 1 minus 2, that is equal to minus 1. So yeah, the value of m and c are 1 and minus 1 respectively for the sixth question. And with that, we go ahead with the seventh question. Find the equation of the line which is having an inclination of 135. See, inclination of 135 means that slope will be tan of 135 and that will be tan of 180 minus 45, which is tan of minus 45, which is minus 1. So we know the slope. They have said that the x-intercept is 7. Now x-intercept is 7 means the line is passing through 7, 0. Okay, we know a point through which the line passes. We know the slope of the line. We will write the equation of line in the slope point form, which says that equation of line is y minus y1, that is y minus 0, equal to m, which is minus 1, into x minus x1, which is 7. Expand the right hand side, that will be minus x plus 7. You can take that minus x on the left, y minus 0 was already y. So when that x goes on the left, x plus y equal to 7 will be the required equation of your line in question number 7. Go ahead with question number 8, and they have given us the vertices of a triangle A, B and C. Find the equation of the lines containing the side BC. Okay, so we know B, we know C. So equation of side BC, we can write it as y minus y1. So let's take B as x1 y1 and let's take C as x2 y2. So y minus y1 will be y minus 0 upon x2 minus x1, that will be 6 minus 0. On the right hand side, it will be x minus x1, that is x minus 2, divided by x2 minus x1, that is minus 1 minus 2. So this will be minus 3. This simply will be equal to 6. If that, okay, y minus 0 will also be equal to y. You can take that 6 on the right. So we will have this entire thing multiplied by 6. Minus 3 and 6 can cancel off each other. And this will become equal to minus 2. And with that minus 2, when you open up this bracket, that will give you minus 2x plus 4. And take all these terms on the left. So you will have 2x plus y minus 4 equal to 0. And yeah, that's the equation of side BC. That's how we are answering the A part of the 8th question. In a similar way, let's try to answer the B part. Now for answering the B part, they are asking you the equation of the median AD. You need to understand that when there's a median AD, median means the line that joins a vertex to the midpoint of the opposite side. So if this is your triangle ABC, the midpoint of BC will be D, and if I join A and D, because D was the midpoint, I can say that AD is the median. So we need the coordinates of D, and we can get that by the midpoint formula. D is the midpoint of B and C. So by midpoint formula, the coordinates of D will be 2 minus 1, that is 1 divided by 2. So the x coordinate is half. Then we have 0 plus 6, which is 6 divided by 2, that will be 3. So half comma 3 are the coordinates of D, and the equation of AD will now be given by the 2-point form. So point A is 3 comma 4. We will treat A as x1 y1 and we will treat D as x2 y2. So the equation of AD will be y minus y1, that is y minus 4, divided by y2 minus y1, that is 3 minus 4. That should be equal to x minus x1, that is x minus 3, upon x2 minus x1, that is half minus 3. Half minus 3, that will be 1 minus 6 the whole divided by 2, that is minus 5 upon 2. And 3 minus 4 will be equal to minus 1. That minus 1 goes on the right. And when you multiply this entire thing with minus 1, you see that this minus 1 gets cancelled with the negative sign you had here. So that 5 by 2 can simply be written on the right hand side only. That 5 by 2 can be written as into 2 by 5. You can take that 5 on the left hand side. So that 5 on the left hand side will make it 5i minus 20. This 2, when you multiply that 2 along with this bracket, you have 2x minus 6. Bring everything on the right, so that will give you the equation as 2x minus 5i plus 20 minus 6, that is plus 14 equal to 0. Okay, and that's how we are finding the equation of the median AD. And yeah, that's how we are answering our B part. Now we need to answer the C part, which says that we need the equation of line which is joining the midpoint of the sides AB and AC. So let's find the midpoint of AB first. The midpoint of AB, that will be obtained by applying the midpoint formula on A and B. That will be 3 plus 2, which is 5 divided by 2. That's the x coordinate of midpoint of AB. And the y coordinate will be 4 plus 0 divided by 2. That is 4 by 2, which is equal to 2. The midpoint of AC, that will be midpoint formula on these 2 points. 3 plus minus 1 divided by 2. That is 2 by 2, which is equal to 1. Then we have 4 plus 6, which is 10 divided by 2. That will be 5. So you need the equation of line joining 5 by 2 comma 2 and 1 comma 5. Let's write it in a little bit of space that I can make here itself. Okay, so let's treat this point as x1 y1. Let's treat this point as x2 y2. So the equation of our required line will be y minus y1 divided by y2 minus y1. That should be equal to x minus x1 divided by x2 minus x1. Okay, so on the left hand side this becomes equal to 3. This becomes equal to 2 minus 5, which is minus 3 divided by 2. Minus 3 by 2 in the denominator can be written as multiplied with minus 2 upon 3. This 3 goes on the right and gets multiplied with 3 here. That 3 cancels off the 3 in the denominator. Open up this bracket along with minus 2. So that will give you minus 2x plus 5. And take all these terms on the left. So that will give you 2x plus y and minus 7 equal to 0. Yeah, that's the equation of line in option C, or that's finally the way you are answering the C part of your 8th question. Let's go ahead with question number 9. You need to find the x and y intercepts of the following lines. So for question number 8 is very clear that the equation of line is already in the double intercept form. So the x-intercept with comparison, you can compare it with x upon a plus y upon b equal to 1. In place of a you have 3, so the x-intercept will be 3. In place of b you have 2, so the y-intercept for the line will be equal to 2. And that's how we are answering the first question. For the second question, see the right hand side is already equal to 1. But this equation cannot be compared with x upon a, because if you want to compare it with x upon a plus y upon b equal to 1, the coefficients of x and y have to compulsorily be equal to 1. Is the coefficient of x 1? It's not. So you need to get that 3 in the denominator, make the coefficient of x as 1, and then you can start comparing. So this equation B, we can write it as x upon 2 by 3. It's like I've taken that 3 from numerator to the denominator. If there's anyone who doesn't get this, you can say that in this particular number, we are dividing the numerator and denominator by 3. So 3x upon 3 will give us x, and here it will be 2 upon 3. Similarly, this term will be rewritten as y divided by 3 upon 2 equal to 1. Now compare this equation with x upon a plus y upon b equal to 1. So your x-intercept will be 2 by 3 and your y-intercept will be equal to 3 by 2. That is, b will be equal to 3 by 2. And yeah, that's how we are answering the b part of the 9th question. In a similar way, try to answer the c part. So for the C part, see, you need to realize that for the double intercept form, the right hand side has to be equal to 1. To make the right hand side 1, we will take this minus 12 on the right hand side. We will have 2x minus 3y equal to minus 12. Now bring that minus 12 on the left, but by division, not by addition or subtraction. So when that minus 12 goes on the left, this will be 2x minus 3y upon minus 12. Split the two terms. The first term will be 2x upon minus 12, that is x upon minus 6. The second term is minus 3y upon minus 12. Cancel off a 3 and that will give you y upon 4 equal to 1. So the x-intercept will be minus 6, that is a will be minus 6. And the y-intercept b will be equal to 4. And yeah, that's how we are answering the C part of our 9th question. Going ahead with the next one. Find the equation of lines which contains the point 1, 3 and the sum of whose intercepts on the coordinate axis will be equal to 0. That means if the x-intercept is k, the y-intercept will be minus k. So the line is passing through k, 0. Because the x-intercept was k, the line passes through k, 0. The y-intercept will be minus k. The sum of the intercepts has to be 0, right? So if one is k, the other has to be minus k. Then only the sum will be 0. If the x-intercept was k, line passed through k, 0 on the x-axis and the y-intercept was minus k. So the line is also passing through 0, minus k on the y-axis. For such a line, the slope will be given by y2 minus y1, that is minus k minus 0, divided by x2 minus x1, that is 0 minus k. In the numerator, you have minus k, in the denominator also minus k. So the slope of this line will be equal to 1. The slope is 1. We know that the line is passing through 1, 3 and that is why the equation of line will be written in the slope point form. The slope point form tells you that the equation of line will be y minus y1, that is y minus 3 equals to m, which is 1, into x minus x1, which is equal to 1. On the right hand side it is simply x minus 1. You can bring these terms on the right and say that the equation of line will be x minus y plus 2 equal to 0. Okay, so that's how we are answering question number 10. Let's go ahead with question number 11. It says that find the equations of lines containing the point A, which is 3, 4, and it is making equal intercepts on the coordinate axis. If a line is making equal intercepts on the coordinate axis, this is one thing that we have discussed earlier, that the slope for this kind of a line will be equal to minus 1. So for this kind of a line, if the slope is minus 1 and it passes through a given point, we can write the equation of line as y minus y1, that is y minus 4, equal to m, which is minus 1, into x minus x1, which is equal to 3. So on the right, when you expand the bracket, that will be minus x plus 3. Take everything on the left, so you are going to have x plus y minus 4 and minus 3, which is minus 7, equal to 0. And yeah, that's the solution for question number 11. Let's go ahead with question number 12. So you need to find the equations of the altitudes of the triangle whose vertices have been given to us. I will find the equation for one altitude. The equations for the other two altitudes, you can find them by exactly the same method, or by which I'll be finding equation of one of the altitudes. So let's say that we have our triangle right here. The triangle is A and the coordinates are 2, 5. This vertex being the vertex B, 6, minus 1. And this being the vertex C, that is minus 4, minus 3. You need the equation of altitude, right? That is, let's say you need the equation of AD. So if we need the equation of AD, we know that this line passes through the point A. If we can get the slope of AD, then we can easily find the equation of AD. AD is perpendicular to BC, and that is why if the slope of BC will be known, the slope of AD will be the negative reciprocal of the slope of BC because they are perpendicular. So let's try to find the slope of BC. The slope of BC will be y2 minus y1, that is minus 3 minus of minus 1, divided by x2 minus x1, that is minus 4 minus 6. So this becomes minus 3 plus 1, which is minus 2, divided by the denominator is minus 10, this becomes 1 by 5. If the slope of BC is 1 by 5, we know that AD is perpendicular to BC. So the slope of AD will be the negative reciprocal of this, that is, the slope of AD will be minus 5. Now AD passes through the point A, and that is why the equation of AD will be written by the slope point form. So the equation of AD will be y minus y1 equals to m into x minus x1, which is equal to 2. So that gives us the equation of AD as y minus 5 equal to minus 5x plus 10. Take everything on the left, so you have 5x plus y, and you can take that 5 on the right and write the equation as 5x plus y equal to 15. And yeah, that's the equation of AD. In a similar way, you can find the equation of the other two altitudes, which can be taken as BE and CF. So the method being the same, I'm not solving it. It's the same very method, and like I said, find the equations of those two altitudes by the same method. Let's go ahead with question number 13. Find the equations of perpendicular bisectors of the sides of the triangle whose vertices are given to you. So again, for this question also, we will find equation for one perpendicular bisector. For the other two perpendicular bisectors, you can find the equations by yourself. The method will remain the same. So here's P, the coordinates minus 1, 8. Here's Q, the coordinates 4, minus 2. And here's R, the coordinates are minus 5, minus 3. The perpendicular bisector means the line passing through the midpoint of QR and perpendicular to it. This line is passing through the midpoint of QR, and the midpoint will be found by the midpoint formula. 4 plus minus 5, that is minus 1, divided by 2, that's the x coordinate. Minus 2 plus minus 3, which is minus 5, divided by 2, that's the y coordinate of this point. So we know this point through which our required line is passing. The required line is perpendicular to QR, and that is why the slope of the required line can be obtained from the slope of QR. The slope of QR, the negative reciprocal of it, will give you the slope of this line because this line is perpendicular to QR. So the slope of QR, that will be y2 minus y1 divided by x2 minus x1. That will give you minus 3 minus of minus 2, which is minus 1, divided by minus 9, that is 1 upon 9. 1 upon 9 is the slope of QR. So the slope of the required line, that will be negative reciprocal of this, which will be minus 9. We know the slope of our required line, we know a point through which our line passes, and that is why the equation of our line will be written in the slope point form. The equation will be y minus y1 equals to m into x minus x1. So this will become x plus half. This will become y plus 5 by 2. Let's multiply the two sides first with a 2. So we will have 2y plus 5 equals to, I know that there's a minus 9 here, into 2 will be minus 18, but we will prefer to take that 2 inside the bracket. So we will have 2x plus 1 inside the bracket. Now try to expand that bracket, which we have just got. So we will have 2y plus 5 is equals to minus 18x minus 9. Take everything on the left, so you will have 18x plus 2y plus 14 equal to 0. If you divide both the sides with 2, this will become 9x plus y plus 7 is equals to 0 upon 2, and that 0 upon 2 will be 0. So this is the final equation of the perpendicular bisector of QR. In a similar way, you can find the perpendicular bisectors of PQ and PR also. I'll leave that job up to you guys, and yeah, we go ahead with our question number 14. So in question number 14, we need to find the coordinates of orthocenter of the triangle whose vertices have been given to us. Orthocenter means the point of intersection of all the altitudes. So if I make the triangle like this, That's A, B, C, and if this is your altitude AD, let's draw one more altitude BC. Sorry, not BC. Let's say CF, and this is another altitude. The point of intersection of all the altitudes. There's a third altitude also. I'm not drawing it here, but the third altitude will pass through the same point. So the point of intersection of the altitudes is the orthocenter, and that orthocenter is what we require in this question. Okay. The coordinates of A 2, -2, the coordinates of B which are 1, 1, and the coordinates of C which are -1, 0. We need to find the equation of any two of the altitudes, and the point of intersection of altitudes will give us our required orthocenter. So let's find the equation of altitude AD. For altitude AD, we need the slope of BC first. The slope of BC will be y2 minus y1 upon x2 minus x1. So this will be -1 upon -2, which is 1 upon 2. So the slope of AD, because AD is perpendicular to BC, the slope of AD will be the negative reciprocal of half, which is -2. The slope of AD is -2 and AD passes through the point A. So the equation of AD will be written by the slope point form, that is y minus y1 equals to m, which is -2, into x minus x1. Okay, this will be y plus 2. This will become minus 2x plus 4. Take everything on the left, so we have 2x plus y. In fact, we will take that 2 on the right. So 2x plus y equal to 2 is the equation of the altitude AD. In a similar way, let's try to find the equation of altitude CF. The slope of AB. The slope of AB will be y2 minus y1 divided by x2 minus x1. So this will give us 3 divided by -1, which is -3. If the slope of AB is -3, CF is perpendicular to AB, and that is why the slope of CF will be the negative reciprocal of this, that is 1 upon 3. The equation of CF is again something which we can find by the slope point form, that is the line passes through C. So the equation will be y minus y1 equals to m, which is 1 by 3, into x minus x1, which is -1. So x minus of -1 will make it x plus 1. This 3 goes on the left. Y minus 0 was y. So on the left it will be 3y. And the equation of this line will be x plus 1 equal to 3y. So you can write it as x minus 3y plus 1 equal to 0. So on the right it will be -1. You can multiply this equation with 2. So on multiplying this equation with 2, we have 2x minus 6y equal to -2. We are trying to solve these equations simultaneously, okay, so that we can get the coordinates of our orthocenter. Subtract the two equations, so 2x minus 2x will be 0. Y minus of minus 6y will make it 7y, equal to 2 minus of -2 will make it 4. So we have the y coordinate of our orthocenter as 4 upon 7, and we can put that y as 4 upon 7 in, let's say, equation 1. So if y will be 4 upon 7, that 4 upon 7 comes to the right. 2 minus 4 upon 7. 2 minus 4 upon 7, that will be 14 minus 4 upon 7. So that will be 10 upon 7. So 2x will be 10 upon 7 and x will be equal to 5 upon 7. Yes. So x upon 7 and y upon 7. X equal to 5 upon 7 and y equal to 4 upon 7. These are the coordinates of your orthocenter for question number 14. Let's go ahead with one last question in this video. The 15th question. N 3, -4 is the foot of perpendicular drawn from the origin to the line L. The equation of L will be what? So from the origin, okay, the line, okay, N 3, -4, okay. So 3, -4 will be a point lying somewhere over here. That's the foot of perpendicular that you have drawn from the origin. So this is the foot of perpendicular. So our required line is looking something like this. This point being 3, -4, this point being the origin, and these two are perpendicular. We need the equation of this line. Now we know that the line passes through 3, -4. All we need is the slope of that line. the slope of this normal that you have drawn from the origin, the slope of it will be y2 minus y1 upon x2 minus x1. That will be minus 4 upon 3. If the slope of this line will be minus 4 upon 3, the slope of our required line will be the negative reciprocal of this. That will be 3 upon 4. That happens because this line is perpendicular to the normal that you have drawn from the origin. Okay, so the slope of this line is 3 by 4 and the line passes through 3 comma minus 4. So we write the equation of the line in the slope point form, which is y minus y1, that is minus 4, equal to m, which is 3 by 4, into x minus x1, which is 3. Okay, this will be y plus 4. Take that 4 on the left. So we will have 4 into y plus 4. Expand the two brackets. So 4y plus 16. Expand that right hand side bracket also. So 3x minus 9. Okay. Take everything on the right hand side. So the equation will become 3x minus 4y. Okay. Take that 9. Take this minus 9 on the left. So you will have equal to 25. Okay, so 3x minus 4y equal to 25 is the equation of our required line in question number 15. Yes, so that's where I am done with discussing whatever I wanted to discuss in this video. I hope that the contents of this video have been somewhere helpful to you in your preparations. Do check out the next video that I've made on exercise 5.4 of straight lines. And yeah, thank you for watching.